Hello, welcome to another TeacherTopian tutorial. We're going to be talking about merge sort algorithms, and this will be under topic 1.2.6 under Edexcel GCSE Computer Science. We've already looked at bubble sort in the other video I posted, which is an inefficient sorting algorithm, certainly for large data sets. Merge sort will be more efficient, especially for large data sets. For small data sets, though, it will be negligible. And there's a little bit more setup involved with a merge sort, so you may even find in some cases of very small lists like this one here that bubble sort might actually be good or even better than merge sort. But generally speaking, for much larger data sets, you do not ever want to be using bubble sort. Edexcel do not require you to understand big O notation, but best average and worst case scenarios for merge sort are n log n, and that's to do with how many stages are needed to sort these numbers, and it uses something called recursion, which again you don't need to learn for Edexcel, but this is just for general knowledge. Conversely, bubble sort was quadratic, so we had a for loop within a for loop for for bubble sort. So merge sort is going to be the one your sorting algorithm of choice if you're choosing between the two for large data sets. But let's see how it works, shall we? What happens is this. Let's say we've got an array. They're all integers in here, all the same data type. The merge sort is what we call a divide and conquer algorithm. Okay, so if they mention, if you see in the exam for Edexcel divide and conquer, they're talking about merge sort or binary search. Both of them are divide and conquer algorithms, and the ones that are not, bubble sort or linear search. So you only really need to learn those four algorithms. There are lots of other ones, there's like insertion sort and lots of others, but you don't need to know them for GCSE Edexcel. So you essentially split this list into two. And you look at this side, 16, 12, 4, 23. And you look at this side. And then you keep on splitting them in two. So we've got 16, 12, 4 and 23 as little groups, mini little groups. There you go. And then finally, we're going to have on their own all our numbers. So we're sort of 4 layers deep. And at this point, what happens is that's stage 1. We call this stage 1. That's stage 1. And let me just move this up a little bit. And stage 2, is then going to be looking at all those numbers which have been separated out into pairs, because this was an even amount of numbers. If it wasn't even, there might be one on their own. Then what's going to happen is it will look at these two, look at these two, look at these two, look at these two, and decide which order they need to be in. So 12 swaps around with 16, 4 and 23 stay where they are, 10 swaps around with 18, 6 and 19 stay where they are. And then it will combine those together, and it will say, okay, out of these 4 numbers, which is the smallest? Okay, 4, then 12, then 16, and 23. So we've got a group of 4 now. And it will do the same here. So it needs 6, 10, 18, and 19. And then finally, it's going to put all of these back together again as one list. And so you need to take the 4 from here, the 6 from here, the 10 from there, 12 from there, the 16 from there, 18 from there, the 19 from here, and the 23 from there. So that's our stage 2, step 1, step 2, step 3. So you can see it sort of goes a bit, if I put these arrows in, a bit like a sort of tree, where it starts off with one list, branches to 2, and branches to 4, and then goes back again. And that's where this, not that you need to know this for Edexcel, but that's where the log n comes in, which is to do with the depth of how many steps you need to look at. So it does require quite a lot of copying and a lot of data, and a lot of those numbers need to be stored in memory. But for large data sets, divide and conquer sorting algorithms are more efficient. So let's look at an exam style question, shall we? A merge sort is carried out on this list. State the number of splits required to complete the sort. Okay, so what we've got here. So when we've got a list of odd numbers, we split them up into 2, where the first would be bigger than the second. Okay, so that's our first split. So 1. So we either have 9, 4, 3, 5, 5, 1, 7. Then split up again. 5, 1, 7. And then split up again to 9, 4, 3, 5, 5, 1, and 7. So now that we're in individual numbers there, what we would be doing is going back the other way to make groups 4 and 9, 3 and 5, 1 and 5, and 7, and putting those all together. 3, 4, 5, 9, and 1, 5, 7, and then finally putting them all back together again. 1, 3, 4, 5, 7, 9. 1, 2, 3, 4, 5, 7. 1, 2, 3, 4, 5, 6. Okay, so 1, 2, 3, 4, 5. I'm going to say it's a little bit ambiguous here, but I think they're looking for 6. 1, 2, 3, 4, 5, 6. I think that's what they're looking for, even though you're technically not splitting that up. 1, 2, 3, 4, 5. Yeah. 1, 2, 3, 4, 5, 6. Yeah, I'm going to go with 6. Pretty annoying question, actually, to be fair. Yeah, let's have a look at it. So we're splitting it here. That's definitely one split. And then we split into 2, 3, and 4. From there, 1, 2, 3, 4, and then you could say we are splitting it then 5. Sorry, let's just remove that because that's already been split. Just the way I've drawn it is a little bit awkward, isn't it? So that, what we would say, is a split. That's one split, that's another split, that's another split, and then we have 4, 5, and 6. Yeah, that's better. Sorry about the confusion there. A little bit fiddly, isn't it? No, I definitely obviously sorted our array with merge sort, but in terms of splits, we had this full array, this list, split it once down there asymmetrically because it's odd. Then we split that one again. We split this one in 2, and then for each individual one, we split those in 2. So that's 1, 2, 3, 4, 5, 6. So the answer here, yes, a really annoying 1 mark question, but 6, based on that interpretation of splitting. Right, here is the list after it's split. Complete the diagram to show the merging steps. Well, we've already done that. I've done the hard work there. So in terms of the merging steps, you kind of have to work it out already, don't you? So what we did was we had 4 and 9, 3 and 5, 1 and 5, 7, and then in terms of two groups, 3, 4, 5, 9, 1, 5, 7, and that would be enough, and then finally it goes down to that one now. So we kind of had to do that anyway as part of our process to figure all of this out. I mean, that question here is related to this bit that we did, but it's kind of useful to do the whole thing in one go just to make sure that we've got the right answer. Explain the effect of a fish. Oh, this is tricky, right? Of using a merge sort algorithm instead of bubble sort algorithm on the original list. The reason this is tricky is that if it was a large data set, it would be an easy answer because merge sort is more efficient than bubble sort, but the thing is, for a very small array like this, you could say that merge sort uses more memory. Merge sort, I'm just going to abbreviate here, more memory, because you have to sort of copy different instances of that list. So I'm going to use a linking word here because it copies itself quite a lot of times. And bubble sort, you could also say bubble sort, less memory. It's less memory because it's sort of in place sorting algorithm. Again, I have to use because to link these two things. I really don't like this question because fundamentally bubble sort is really the most inefficient sorting algorithm there is out of all the ones that are possible you could use, insertion sorts and merge sorts and other things. It really isn't the most efficient, especially if you've got o to the power of n squared, quadratic. But because it's such a small array, you could argue in this, and I think this is what they're alluding to, that because merge sort has to copy itself so many times in memory and all these different steps, it might be inefficient and use more memory than bubble sort. But yeah, pretty irritating question, to be honest with you. Sorry about that. For small, I'm going to say this is okay for small data sets. For small data sets, but as soon as you get into large data sets, you do not want to be using bubble sort. Good. Okay. Irritating question there, but we went through merge sort, which is one of the trickier topics to go through. So well done.